attention here.
Of any square or rectangle using our formula. We're going to learn the formula for finding the area of any triangle. But to do that, we're going to start with a rectangle. What? The dimensions of this rectangle are 3 meters by 4 meters.
So how do you find the area of that rectangle? What's length times width, right? Length times width. So someone tell me right now, what is the area of this rectangle?
12 meters squared.
Jason?
12 meters squared.
12 meters squared is 12 square meters. Okay, good.
So, what's its area? Well, using our formula, we know that the area would be 3 meters times 4 meters, which is 12 meters squared. But now, what if we were to cut this rectangle exactly in half along a diagonal line from opposite corners? It forms 2 triangles. And because each of these triangles is exactly half of the rectangle, that means that the area of either triangle must be exactly half the area of the rectangle.
So what does the area of each of those triangles have to be? 6 square meters. So you have 6 square meters, and then you have 6 square meters. You add them together, and you get a full 12 meters squared. So based off of that, make a prediction. How do you find the area of one triangle? How did you find the area of that 6? You took the area of the rectangle, which was what? Length times, and did what to it? Divided it by 2. Or you could say that you took half of length times width, because what is half of 12? 6. Okay? Good.
We calculated that the area of the entire rectangle is 12 meters squared. So the area of this triangle must be 6 meters squared. And the area of this triangle must be 6 meters squared, since 6 is half of 12. Aha! So the formula for the area of a triangle should just be half of a rectangle. So does that mean that instead of area equals length times width, it should be area equals 1/2 of length times width? Yep, that's basically it, but with one important difference.
Okay, this is very important. Make sure you watch this. This is where we're going to go from length and width to base and height. How many of you know why we go from length and width to base and height? Anybody? Why can we not use length and width for triangles?
Length and width for triangles because it doesn't have full right angle.
Good. All triangles are not going to be what's called a right triangle, where you have this 90 degree. This is my base and this is my height. Would you agree? Do all triangles look like this? No. So that's why we have to get away from length and width, because of what is going to be said right here.
Instead of L for length and W for width, we're going to use 2 different names for our triangle's dimensions. We're going to call them base and height, and here's why. The names length and width worked okay for this right triangle, because the right triangle is exactly half of a rectangle. But those names don't really work for other kinds of triangles, like acute triangles or obtuse triangles, because how do you tell which side should be which? So for triangles, we do something different. First, we choose one of the 3 sides to be the base. It doesn't really matter which side you choose, and in a lot of math problems, the base will already be chosen for you. Once we decide which side the base is, we imagine setting the triangle down on the ground so that its base is flat on the ground.
So as you look at this, you put the base on the ground. Where would your height be on that triangle? If you measure the height of something, don't you want to do the highest point? So where would I measure to? Ori?
From the right side up to the tallest point.
So you would say go to the tallest point, right? Do we want to go here to here? Is that my height? Well, no, when you measure your height, what do? Straight up and down. So your feet are at a 90-degree angle with the floor. Well, it's the same thing with this. When we measure this height, what he's going to talk about in a second, we want to go straight down. Or he also shows that we could show it over here and go straight down. So that's why we cannot use these as your height, because that's not your height. Okay?
Like this. Next, we find the highest point of the triangle, which is the vertex that's not touching the ground. From that point, we draw a line straight down to the ground. The line we draw must be perpendicular with the ground.
Okay, good. So what is the relationship between base and height? He just said it. This height must be what to the base? Perpendicular, which perpendicular means what? It meets the base at a
Right.
right angle. Good. Parallel. Parallel is when you have railroad tracks, right? They never touch. Perpendicular is like the exact opposite. They're going to meet, but they have to meet at a 90-degree angle. Okay? That's a question that's on an exit slip, and that question is on the test. What is the relationship between base and height? How do they always have to meet each other? What's the answer? At a 90-degree angle. Okay, good.
The length of that line from the tip of the triangle to the ground is called the height of the triangle. Oh, some people call the height of a triangle the altitude, which makes a lot of sense if you pretend that your triangle is a tiny little mountain. Sometimes the height line is inside the triangle, like with an acute triangle. And sometimes it's outside the triangle, like with an obtuse triangle.
So when you see a dotted line, is that really a part of the triangle? No, it's kind of like an invisible line. What's it showing you? It's just showing you the height. So sometimes people get confused. They're like, well, I see two triangles, this triangle and this triangle. This is just showing you what this height is. This has nothing this is not forming another triangle. Does that make sense? Okay? So it's just showing you what that distance is, and then your base is still just going to be this right here. It is not the entire thing. This is like an invisible line.
And sometimes it lines up exactly with one of the triangle sides, like with right triangles. But no matter where it is, the formula for finding the area of any triangle is the same. Area equals 1/2 base times height. So if we know these...
So let's explain that. Let's say that the base times the height was 12, like we said earlier. What's half of 12? That's what this is saying. Half and multiplication, what word do we use? Of. So half of 12 is, or you could do base times height and divide it by, because what's 12 divided by 2? 6. You can, either way you want to do it is fine. You can say, okay, what's half of that? So that means multiply by half, or you could divide by 2.
two measurements, base and height, we can just plug them into our formula to calculate the area. At first, you might not see how the same formula could work for all three types of triangles, but watch this. Here's an acute triangle, and this box is 1/2 its base times its height.
So this is very important. So you're saying, well, that doesn't look like half of it. Watch this. This is why I wanted to use this video.
If we cut our triangle up, you can see that it fits perfectly inside that area. But wait, there's more. Here's an obtuse triangle with a box that's 1/2 its base times its height. Again, if we cut up the triangle, it fits perfectly inside the box. Now you can see how the formula, area equals 1/2 base times height, works for any kind of triangle. Okay, we already figured out that the area of this right triangle was 6 square meters. So let's practice using our new formula to calculate the area of these last two triangles. Our diagram shows that the base of this acute triangle is 5 meters, and its height is 8 meters. So we plug those values into our formula for area.
So what did we get here? What's the area of this triangle? It's 5 meters times 8 meters, which is
40.
And then I can either say, okay, what is half of that? What's half of 40?
20.
Or you could say 40 divided by 2 is
20.
20.
And we get
20
area
meters squared.
equals 1/2 of 5 times 8. 5 times 8 is 40. And 1/2 of 40 is 20. So the area of this triangle is 20 meters squared. Don't forget that the units of measurement for area will always be square units. Okay, that was pretty simple. Let's try our last example. The diagram of this obtuse triangle tells us that the base is 4 inches and the height is 7 inches. So let's...
Someone say the problem to me. Use labels. That's one thing I don't like about what he's doing there when he plugs these numbers in. He doesn't use his labels. Use the labels. How would you write this out on your paper? You'd say half, parentheses, what? Lacey? 4. Very good. 4 inches times 7 inches. 4 inches times 7 inches is? 28 inches divided by 2? 14 inches squared.
Plug those values into our formula. We end up with the equation, area equals 1/2 of 4 times 7. 4 times 7 would be 28, and then we can calculate what 1/2 of 28 would be by dividing by 2. 28 divided by 2 is 14. So the area of this obtuse triangle must be 14 square inches.
All right, good. Thanks, John.